Hello friends, myself Prof. HK. Today we learn new topics. Topic name is a dynamic of a circular motion. In this topic we can discuss two forces. First is centripetal force. Second one is a centrifugal force. First we can discuss centripetal force. Definition of a centripetal force: force acting on a particle performing circular motion which is along radius and directed toward the center is called centripetal force. See this diagram. Consider P be the any particle performing uniform circular motion along the circumference of a circle of radius small r. O be the center of this circle and V be the tangential velocity of the particle. Centripetal force act at right angle to the tangential velocity of particle. There is no displacement in the direction of a force, hence no work done by centripetal force. See this diagram. The direction of force toward the center and direction of the tangential velocity in this way, both are perpendicular to the each other, hence there is no work done by the centripetal force. According to Newton's second law of motion, force is equal to mass into acceleration. Here centripetal force denoted by F suffix Cp, mass denoted by m, and acceleration is a. Then we can write formula F suffix Cp is equal to m into a. Then a is equal to v into omega, but we know that the relation between angular velocity and linear velocity is v is equal to r omega. Then this acceleration we can write v square upon r. Again this equation we can write a is equal to r omega square. Then F suffix Cp is equal to m into v into omega. Again we put value of omega is equal to v upon r. Then F suffix Cp is equal to m v square upon r is equal to m into r into omega square. Consider equation number first. These all equation consider as a magnitude of a centripetal force. Then this equation first we can write in a vector form. F suffix Cp bar is equal to minus m v square upon r into r cap, or we can also write minus m omega square into r bar. This is a vector form of a centripetal force. In this formula we can use some notation. Here m is the mass of the particle performing uniform circular motion, v linear speed of a particle performing uniform circular motion, small r be the radius of circle, r bar radius vector and r cap is the unit vector in the direction of a r bar. Then what is the unit of a centripetal force? SI unit of a centripetal force is newtons, CGS unit Dine, and dimension of a centripetal force is L raised to 1, M raised to 1, T raised to minus 2. Some example of a centripetal force. First example, when an object tied at the end of a string is viral in a horizontal circle, the necessary centripetal force for maintaining circular motion is provided by tension in the string. Another example, moon revolves around the earth in a circular orbit. Here, the necessary centripetal force is provided by gravitational force of attraction between moon and earth. These two examples of a centripetal force. Some notes we can prepare. It is also say property or characteristic of a centripetal force. First characteristic, it is act along radius of a circle and directed toward the center of circle. Second one, it is a real force. Third characteristic, it is originated in an inertial frame of reference. Fourth one, it is cause of circular motion. And fifth one, it is responsible for UCM. These all characteristic of a centripetal force. Another type of force is a centrifugal force. What do you mean by centrifugal force? Definition: a pseudo force in UCM which act along radius and directed away from the center of circle is called centrifugal force. Again, we see this diagram. P be the any particle performing circular motion along the circumference of a circle. O be the center of this circle. Small r be the radius of this circle. According to Newton's second law, the magnitude of centrifugal force is F suffix Cp. Here we can denotes centripetal force F suffix Cp, Cf. According to Newton's second law, F suffix Cf is equal to mass into acceleration. Then we can also write F suffix Cp is equal to mv omega. Again we put value of omega is equal to v upon r. Then this equation we can write F suffix Cf is equal to mv square upon r is equal to r omega square. Consider equation number first. These all equation are the different form of magnitude of a centrifugal force. Here using some term, P is the particle in UCM, F suffix Cb bar is a centrifugal force, r be the radius of circle and r bar is the radius vector. This centrifugal force we can write in a vector form. F suffix Cf bar is equal to mv square upon r into r0 cap, where r0 cap is the unit vector in the direction of a r bar. What is a unit of a centrifugal force? SI unit of a centrifugal force is Newton, and CGS unit is dyne. Dimension of a centrifugal force is L raised to 1, M raised to 1, T raised to minus 2. Then we can discuss example of a centrifugal force. First example, when a car in a motion take a sudden turn toward the left, passenger in a car experience an outward push to the right. This is due to centrifugal force acting on the passenger. Another example of a centrifugal force, the children sitting in merry-go-round experience an outward pull as merry-go-round rotate about vertical axis. This is due to centrifugal force acting on a children. Some note prepare about centrifugal force. This note consider as property or characteristic of a centrifugal force. First, it is acting along radius of a circle and directed away from the center of the circle. Second property, it is an imaginary force. Next property, it is originated in a non-inertial frame of reference. Fourth one, it is the effect of circular motion. Fifth one, it is not responsible for UCM. In this way, we can discuss two forces. What I mean by centripetal force, what is the SI unit, CGS unit, dimension, and example of a centripetal force, centrifugal force. Again, we discuss new topics. What is the difference between centripetal force and centrifugal force? Centripetal force, first point, consider as a definition. In centripetal force, force acting on a particle performing circular motion which is along radius and directed toward the center is called centripetal force. Next, centrifugal force. Definition of a centrifugal force: a pseudo force in a UCM which act along radius and directed away from the center of circle is called centrifugal force. Second point, centripetal force is a real force. In a centrifugal force, it is an imaginary force. Third point, it is originated in an inertial frame of reference. In centrifugal force, it is originated in a non-inertial frame of reference. Fourth point, in a centripetal force, it is responsible for UCM. In a centrifugal force, it is not responsible for UCM, uniform circular motion. Fifth point, in centripetal force, it is causes of circular motion. In a centrifugal force, it is the effect of circular motion. 6.1 Vector form of a centripetal force: F suffix Cp bar is equal to minus m v square upon r into r0 cap. And vector form of a centrifugal force: F suffix Cp Cf bar is equal to m v square upon r into r0 cap. Another point, 7 number, figure of these forces. And last one, it is act along radius of a circle and directed toward the center of circle. In a centrifugal force, it is acting along the radius of circle and directed away from the center of circle. In this way, we can distinguish between centripetal and centrifugal force. Today, we discuss new topic, dynamics of a circular motion. In dynamics of a circular motion, we can discuss two forces, centripetal force and centrifugal force, a definition, its units and example. Today, stop here. Thank you.